Good afternoon to the doctor. So today we are going to present on the simplex method. So this is the one of the example we have found, and so the example is given by minimize negative z equals to negative 8x1 minus 10x2 minus 7x3, subject to x1 plus 3x2 plus 2x3 less than or equal to 10. Then the second equation is negative x1 minus 5x2 minus x3 more than equal to negative 8. And the sign restriction is that x1, x2, and x3 is more than or equal to 0. So since this is a minimization equation, we need to convert it into the maximized equation by multiply negative on the both sides. So after multiplication, we get the equation of maximized z equals to 8x1 plus 10x2 plus 7x3. And for the equation 2, so we need to change the sign from more than or equal to less than or equal to. We can do this by using the same methods as well, which is multiply negative 1 on the both sides. So after multiplication, we can get the equation of x1 plus 5x2 plus x3 less than or equal to 8. So after that, we need to add a slack variable into each equation. So since the first and second equation that we get is less than or equal to, so we need to add slack variable 1 into the first equation and slack variable 2 s2 into the second equation. So next, after we get all the equation, we need to form a simplex table. So as we can see, this consists of variable s1, s2, s3, s1, s2, z, and also b, which is the right hand side value. So we insert the value of this equation into the table. This is the table as shown. So after that, this is the initial table. Then we need to determine the optimality by checking the row at the bottom here, which is the maximized z equation row. So since there is still a negative coefficient in the bottom row, so we still need to do the ERO to determine the optimal basic feasible solution. So here we can see that the most negative coefficient is the x2, which is negative 10. So we determine x2 as the entering variable at here. So after that, we need to determine the ratio. We need to conduct the ratio test to determine which row to be the pivot row. So from this indicator, it shows that the row 2 has the smallest value from the ratio test. So row 2 will be the pivot row and enter the variable x2. So next, we need to create a new table by using ERO. So initially, this is the second row equation, which is made up of 5x2. So we need to reduce it to the coefficient of 1. So by doing that, we need to multiply the whole row by 1 over 5. So each value of this need to multiply by 1 over 5, and we get this new second row, which is the new pivot row. And from the pivot row, we need to use the pivot row and make the other row become 0 coefficient in the variable x2. So since this is the coefficient is 1 in x2, but the coefficient is 3 in the previous row 1, so we need to multiply the pivot row by negative 3 and then add with the initial row 1, and we will get the new pivot row 1. So is this also is a, this the bottom row is also the same, which is previously it is negative 10, and so we use the pivot row to multiply by 10 and then add with the previous bottom row, so we will get the value of this table. Okay, next I will pass to my friend to continue with the simplex method to determine the most optimal basic feasible solution. From
哦，这讲啦。So，你讲哪里？你讲这里看。接下来啊，OK。Hi, my name is Tan Shen Hian, Mr. Mac number 185900, and now I will continue on the simplex method of getting an optimal solution. So after we get the first new W, we need to check on the optimality. So how to check on is it the solution is optimal? We have to check on in this case, we need to check on the last row to make sure that there's no any negative coefficient in the last row. So in this case, there are still negative coefficient in the last row. So we need to make a new W until there is no negative coefficient in the last row. So now we need to identify a new pivot variable by doing ratio test. Before that, we need to know the entering variable. So we need to choose the smallest value as our entering variable. In this case, it's x1 because the value is -6 for the last row of x1 variable. So x1 will be our entering variable in this case, and we need to determine the pivot row by determining the ratio. As you can see, if we after we found out the ratio test, we know that the ratio for row 2 is smaller, which is 8 compared to 13. So we will use row 2 as our pivoting row. Now, after determining the entering variable and the pivoting row, we need to carry out ERO to create a new W. In this case, we need to make the pivot variable 1 by multiplying the row containing the pivot variable by the reciprocal of the pivot variable. Before that, you can see the value is -6. Okay? You can see the value is 1/5. So we need to multiply with the reciprocal of 1/5. So everything is multiplied by 5, and then so that we can get the value of 1. After getting value of 1 for the row pivoting row, we need to use this pivoting row as the basis to either uh, combining with other row or subtracting with other row to make the other coefficient become 0. So we can use this row, which is 1 multiplying by -2/5 and add it into row 1 so that we can make this variable become 0, and so that the new W we look at similar something like this, and then we'll get a whole new W. And once the W is completed, we need to check again, is it the So continue after we get the new tableau. We need to check again is it the solution is optimal. So we need to check again the last row of the tableau, is it there's any negative value. If there isn't, that means the solution is optimal. So now, as you can see the tableau, there is no negative value in the last row, so that we can determine that this solution is optimal. After that, we need to identify the basic feasible solution. We know that the basic variable is s1, s1, and z because there's only one coefficient in the row. And the non-basic variables is x2, x3, and s2. So after we determine the basic variable and the non-basic variable, we know that we can find the solution where the x1 equals 8 and the s1 equals to 2 and z equals to 64 and the others are equal to 0. In this case, we can conclude that the maximum optimal value is 64 and found at 800 of the objective function. So as a conclusion, the simplex method is an approach to determine the optimal value of a linear programming by hand. And the methods produce an optimal solution to satisfy a given constraint and provide a maximum value. To use simplex method, linear programming model needs to be converted to standard form where select variables can be introduced. And by using tableau and period variables, an optimal solution can be reached. And as a conclusion, from the example we found out that the answer is the optimal objective value is 64. It can be found as the value of x equals to 8, x2 equals to 0, and x3 equals to 0. That's all for this example. Thank you.
Okay, hi. So I'm going to present to you the second example of linear programming solved by simplex algorithm. So for this example here, the question is we are going to solve the max problem z equals 120x1 plus 160x2 with the following constraint. Okay, so the first step is we are going to convert the linear programming into the standard form. Okay, so where we are going to add a slack variable. Okay, if the constraint is this less symbol with the less symbol. So from the standard form that we will get here, you will see here 2x1 plus s1 equals 10, 3x2 plus s2 equals 11, x1 plus x2 plus s3 equals to 5, and these are the sign restriction over here with x1, x2, x1, s2 and s3 larger than 0. Okay, so for the second step, we are going to obtain a basic feasible solution from the standard form that we obtained above. So from the basic feasible solution that we can get, okay, so we'll get that since s1 is the only one variable for the row, so the basic feasible solution that we get is s1 equals to 10, s2 equals to 11, s3 equals to 5, while the x1 and x2 equals to 0. So for the third step, we were going to determine the basic feasible solution is optimal or not. So then we plot the initial tableau in a proper form. So where you can see here is a simplified tableau. So the z, okay, so from the objective function, you can see that the z is 1. Okay, so here the x1 is negative 120 is because we convert the we move both of these variable into the left side and we equals the objective function equals to 0. So we get z minus 120 minus 160 x2 equals to 0. Okay, so this So from the first row, okay, we can actually determine the solution is optimal or not by looking at is there any negative coefficient. So as we can see here, there's a 2 negative of coefficient, so it is not optimal. Okay, so move on to the next row. Okay, so this is the result that we convert the standard form into the tabular form. Okay, so after that we are going to determine the entering variable over here. So you can see that which one for the x1 and x2 itself, so which one have the highest negative coefficient. So as we can see, it's a negative 160. Thus x2 can be labeled as our entering variable. So by having this, we are going to perform a ratio test. So after we perform a ratio test, 11 divided by 3 for the S2 and 5 divided by 1. Okay, so we'll get the ratio test 11 over 3 and 5. So the smallest value of the ratio test will determine as our pivot point. Okay, so after that, we can see that okay, so we can see over here one okay, so we move on to the ERO. Okay, after we perform the ratio test, and then we are going to eliminate. Okay, we're going to make the x2 as our point here. Okay, so these are the elementary row operation to solve the new basic feasible solution. Okay, so now I will pass it to Wilson, and Wilson are going to explain to you the rest step for the feasibles the rest step for the ERO operation.
Okay, so after what has been done by the previous members, Chuan Kang Wei, so we are going after that, we will have to identify which is the actual values of the optimal basic feasible solution for it. So from the objective functions, we can see that there is still a negative 120 of a negative coefficient in x1. So that from that we know that it is not an optimum solution yet. So we will have to repeat from the previous step. So we start from step 3 again. So by determining it is not optimum, so we will be using x1 as our pivot rows, and then after that from step 4 we are going into to identify which is not the basic variables and which is the non-basic variables. So based on what you can see here, after that we have chosen x1 as our pivot rows. We will do the ratio test, and then from the ratio test itself we can found that from row 1 we have a 5, and row 2 we have none because it has 0 values, and from row 3 we got a 4 over 3. So based on that, from row 4 over 3 we know that that is the smallest values of it. So by doing it, we know that row 3 is going to be our next W to plot from. So by doing the ERO methods, so the ERO methods will be having the same things as we use row 3 as row 3 prime prime double prime, so that we will get another values of the next W, and based on that we got a new W from that, and we call it a basic feasible solution in the second iterations. Table 5 is it, this is it, so you can have a look. By having the first one row 3, we do it, and we will get row 0 double prime, row 1 double prime, and row 2 double prime. So based on that, you can see that the right hand side itself is 2240 over 3 is a fraction number, but from that we will have to identify again is the solution a basic feasible solution. So from row 0 you can see that there is no negative values, negative coefficients anymore, and so that we we can say that this is the basic feasible solution for these questions. And since we have no more negative coefficients, we will have to look for the items which we would like to obtain from. So from the objective function value, which is this 2240, so you can basically look from it from the right hand side itself. And how do you identify? You can identify it by using the column which has 1 and the other has zeros. So from for x1 you know that it is 4 over 3 because they have 0 over here. For x2 you know it's 11 over 3 because you can take a look over here. And s1 itself is a 22 over 3. So this is what I have plotted out. Then you can have a look. This is the answers. So after that, you will have to calculate for the revenues itself. So by substituting the values of our x1 and x2, and you can calculate the revenues of it is 746 ringgit point 67 dollar. So this is it. Thank you.